we will discuss another concept. What are the factors affecting on the rate of reaction? Factors of rate of reaction. Factors affecting on, simply factors of rate of reaction. Factors affecting on rate of reaction. There are various factors depends on the rate of reaction. The first one is the nature of reactants and product. Nature of reactants and product. What is the nature of reactants and products, sir? Simply, nature of reactant means physical states of reactants and products. For example, if you take physical states, of reactants and products. What is the physical solids, liquids, gases? Generally rate of reaction for solids, liquids and gases, always gases is greater than liquids is greater than solid. Next one, one more, rate of reaction of homogeneous medium. If you take ROR, rate of reaction of homogeneous mixture is greater than rate of reaction of heterogeneous mixture. Heterogeneous medium or mixture. Okay, these are the physical nature. Or if you take chemical nature, of reactants and products. Chemical nature of reactants and the products. Here, chemical nature means types of reactions. Here, some reactions are very fast. Generally, ionic reactions are faster than the molecular reactions. Ionic reactions means especially precipitation reactions. For example, now I am taking a precipitation reactions. What is precipitation reaction here? A sodium chloride is reacted with silver nitrate to produce silver chloride and sodium nitrate. It is a very fast reaction. Whereas molecular reactions, it is a very, very fast reaction. If you take molecular reaction, means here nitric oxide combines with oxygen molecule to form nitrogen dioxide. Here bond breaking, bond making takes place. It is very slow when compared to the ionic reactions. It is the first factor. Nature of reactants and product. And second factor is concentration of reactants. Rate of reaction is depending on the concentration of reactant. For example, NC products is there. The rate of reaction is directly proportional to the product of concentration of reactant, with each concentration term raised with some power. That is equal to K into concentration of C power N. The rate of reaction is directly proportional to the concentration of reactant. For example, the rate of burning of wood, if you take wood, it depending upon the concentration of oxygen. A piece of wood burning slowly in air, the percentage of oxygen only 20%, but burning rapidly pure oxygen, 100% oxygen, because concentration of oxygen in air is less than concentration of pure oxygen. Okay, that means the rate of reaction is directly proportional to the concentration of power n. R is equal to K into concentration per N. If you take for gaseous reactant, ideal gas equation PV is equal to NRT. So the gas is obtained. The gas equation is obtained from Boyle's law, Charles' law, and Avogadro's law. Is called ideal gas equation. PV is equal to NRT. Where P is equal to N by VRT. Where P is equal to CRT. And also here R and T are the constants. P is directly proportional to C. Already you know here C is directly proportional to rate. Like that rate is directly proportional to P only. That means instead of this one, rate is directly proportional to P power N only for gaseous. Here if the concentration is more, number of molecules in unit volume will be greater. If the concentration is more means the number of molecules in unit volume will be greater, then the number of collisions also will be greater. So the rate of reaction also increases. That means here rate is directly proportional to concentration of reactant. This is second one. I hope it is clear. And third one is temperature. So what is temperature? The degree of hotness or coldness of the body is called temperature. In generally, on increasing the temperature increases the rate also. Almost all chemical reactions. On the other hand, decrease in the temperature, decrease in the rate. It means rate is directly proportional to the temperature. As the temperature increases, rate of reaction also increases. As the temperature decreases, okay, this effect is observed for exothermic and endothermic reactions. Already you know. In most cases, rise of 10 degree, every 10 degrees Celsius, the temperature is raised twice times. That is equal to, in most cases, rise of 10 degrees Celsius in the temperature generally doubles the specific rate of reaction. In most of the cases, every 10 degrees Celsius, the specific rate can be double. That is equal to temperature coefficient. Temperature coefficient T is equal to T degrees Celsius plus 10 by T degrees Celsius is approximately double. So what is the temperature coefficients are here? The rate is measure the ratio of two specific rates. The ratio of two specific rate. The ratio of two specific rates measure at temperature the ratio of two specific rate measure at a temperature, the difference by 10 degrees Celsius. That difference by 10 degrees Celsius is called temperature coefficient. Arrhenius equation for temperature dependence of rate constant. Already you know before modified Arrhenius equation. Log K2 by K1 is equal to EA by R 1 by T1, that is EA by 2.303. That is the log modified Arrhenius equation. Already you know. Log K2 by K1 is equal to EA by 2.303 R T2 minus T1 by T1 T2. This is the various temperatures. Arrhenius equation, rate depending on the temperature. Here we can conclude that temperature, as the temperature increases, the number of collisions between the molecule also increases. As the number of molecules increase the internal energy of the molecules, and hence increase the rate of reaction. Okay, this is information about temperature. The fraction of molecules versus kinetic energy. Fraction of molecules versus kinetic energy. So take small graph here. This is fraction of molecules. This is kinetic energy. Okay, this graph you can observe here. That is every 10 degrees Celsius. T plus 10, this is T. This is the fraction of molecules. This area shows fraction of additional molecules which react at 10 degrees Celsius. Fraction of molecules reacting. Okay, this is fraction of molecules. Fraction of molecules reacting at T. Reacting at T here, and also this area. That means here you can observe. Another factor is catalyst. What is a catalyst, sir? Catalyst is a chemical substance which alters the rate of reaction. It is a chemical substance which increasing or decreasing the rate of reaction. The catalyst is a chemical substance which alters the rate of reaction without participating in the reaction. It is a chemical substance which alters the rate of reaction. Which alters the rate of reaction without participating. Without participating. Without participating in the reaction. What are the main points of some important points of catalyst here is there? That is, catalyst never participating during the chemical reaction. Catalyst does not participating in the reaction. Catalyst never participating in the during the course of reaction. Catalyst never initiate the reaction. Never participate, never initiate. Catalyst does not change average energy level of the reactants and products. Catalyst does not change average energy level of reactants and product. Catalyst also does not change. Catalyst also does not change. Catalyst also does not change. Does not change. Delta is change in Gibbs energy. Delta H change in enthalpy. Delta S change in entropy. Kc equilibrium constant. Catalyst does not change in Gibbs energy. Change in enthalpy, change in entropy, Kc. Catalyst does not initiate, catalyst does not change in enthalpy, change in Gibbs free energy, and Kc. And catalyst does changes. Catalyst which alter only rate of reaction, and as well as a path of reaction, activation energy, path of reaction, activation energy, threshold energy, rate constant. Threshold energy and as well as a rate constant. These are the conditions. Catalyst is required in small amount. Catalyst provides alternative path to reaction in which threshold energy will change due to which activation energy also changes due to the rate of reaction also changes. These catalysts are classified into two types. Okay, one is a positive catalyst, another one is a negative catalyst. Positive catalyst, second one is negative catalyst. Positive catalyst. The function of positive catalyst to lower down the activation energy. The function of this one is lower down, means decreasing the activation energy. Negative catalyst to increase the activation energy. If the lower down the activation energy means greater the decreasing the activation energy, higher will be the rate. Here decreasing the rate activation energy means rate of reaction is increases. Rate increases. Here rate of reaction will be decreased. In the presence of catalyst, the rate of the reaction follows the path of lower activation energy. In this condition, a large number of reacting molecules are able to cross over the energy barrier. The rate of reaction will be increases in the positive catalyst. To take negative catalyst, increasing the activation energy of the reaction by forming a new intermediate high energy by changing the reaction mechanism due to increasing activation energy. Some activation energy, if the activation energy is increases, rate of reaction will be decreases. Variation of K on addition catalyst. Variation of rate constant with the catalyst. Okay, here already you know K is equal to A into e power minus A by RT. Without catalyst, this one. If you take with catalyst, positive catalyst, now I am taking here. With positive catalyst means decreasing the activation energy. With the positive catalyst, K dash A e power minus A dash by RT. This is equation 2. Divide equation 2 by 1. K dash by K is equal to A into minus A dash by RT divided by A into minus A by RT. Here K is inversely proportional to the activation energy. By taking logarithm on both sides, ln K dash by K is equal to, here these two r gets cancelled by applying of logarithm log a power m by a power n K e power A by RT minus A minus A dash by RT. Log K dash by K is equal to A by A minus A dash by RT. So here ln is nothing but 2.303 log. K dash by K is equal to A minus A dash by RT log of K dash by K is equal to A minus A dash by 2.303 RT. And another factor is surface area. As the surface area increases, the rate of reaction also increases. Another factor is surface area. Surface area. As the surface area increases, rate of reaction also increases. And pH of acidic and basic medium. pH of medium, acidic or basic medium. pH of medium. pH of medium. Electric and magnetic fields. Electric and magnetic field. That means polar and non-polar molecules. Electric and magnetic fields also rate of increasing the rate of reaction, and explosion of radiation. Explosion of radiation. The explosion of radiation is also directly proportional to the rate of reaction. If the radiation increases, the rate of reaction also increases. These are the factors that depends on the rate of reaction. Thank you one and all. Have a nice day.